Good day. My name is Nur Shazrin and my partner is Nur Zakira, and today we are going to explain more about our project, which is Android device routing. Android phone runs an operating system designed for commercial and private use. Like most operating systems, several features are disabled. Phone manufacturers lock their devices to prevent you from damaging the phone and exposing the phone to the security risk. They also lock devices to prevent you removing the apps they installed or from switching carriers. Routing remove all the limitation and grants full access to the operating system. The advantages of routing your Android phone is the first one is running apps, special apps. Routing allows the phone to run apps that it cannot run otherwise. Other than that, it can removing pre-installed apps and also freeing up memory. However, there are some disadvantages of routing, which is risk a breaking phone. A brick phone is completely unusable, and the second one, poor performance. The intention of routing a phone is to improve the phone performance. However, some users who root their phone to speed it up or add additional features find their devices lose both performance and the features. The objective of this project is to familiarize the process of device routing. The second one is to gain the knowledge of Linux system and Android operating system. Next, we move on to the procedure, result, and discussion. Before we start discussing about the procedure, we have created two VM which involved in this project. The first one is the seed Android, and the second one is seed Ubuntu. For the first task of this project, it is to build a simple OTA package. In this task, OTA package is created from scratch. The focus is to inject a program into the Android system from the recovery OS and let Android run the injected program using the root privilege. To make it easier, dummy file was created in the root privilege. There are three steps in this first task that will be covered here. The first step is update the script, write the update script. In the recovery OS, the first OTA package that will be executed is update binary file. In this task, update binary and damage.sh was created. The purpose of the update binary is to inject dummy.sh to the Android OH. Okay, the first step is we create new directory task. Meta in inf /com/google/android was made. All the necessary file, which is dummy.sh and update binary, was created. As you can see, all the necessary file is being created. The second step of this first task is to build the OTA package. Implementing the OTA package is put all the file in the corresponding folder so it can maintain the same structure. Put the dummy together with the update binary in the same location. As you can see, all the file was zipped in task 1 folder. After creating an OTA package, the step 3 is to run the OTA package. In this task, the OTA package need to be unpacked by doing unzip. After that, find the binary file and run it, and now the Android has been updated. The Android VM was rebooted to see whether the test file is present. So as you can see, the first figure 7 Android recovery was logged in and IP address was checked, and then send the package from the mobile seat to the recovery and place it to the folder of recovery OS, unzip the file and update the binary and reboot and check the file. For the next 2 tasks and the conclusion, I will pass to my friend Zakira. Thank you.
So in the previous task, the init.sh file was modified to make our injected program to run automatically and with root privilege. But for this task, which is task 2, another approach was used to inject the program, which is via app process. When Linux part on Android was initialized, Android OS will bootstrap its runtime that is built on top of Linux to run a program called app process using the root privilege. So this app process will start the Zygote daemon, which its function is to start an application. So for this task, a modification will be made toward the app process file to make it launch something that we set along with the launching of the Zygote process. And similar to the previous task, OTA package will be built through creating an update binary file in the similar structure of folder hierarchy. So I will now present the procedure of how we perform this task. Firstly, before we start with anything, we boot up the Android OS first and go to the system directory to check its content, because later in this task we are going to create a file named dummy2 with the OTA package we built. So based on the picture, there is no dummy2 file exists in the directory. Then we can go to the next step to create the directory for our task2 package in the seed Ubuntu OS. The directory will be task2/metainf/com/google/android. This directory structure is the standard file structure for OTA package, and we always need to maintain this structure to build the package. Next, we create a new folder named task2 code to create all the necessary files needed, which are my appprocess.c, application.mk, android.mk, and compile.sh. And for the file that need to be executed later, which is compile.sh, we change the permission of the file with command chmod a+x to make it executable. So from this picture, we can see that the executable file will be listed in green color font, and this other 4 picture is the content for my appprocess.c, application.mk, android.mk, and compile.sh. Compile.sh will build the application.mk file, where its app build script point to the android.mk. So executing this process later will also compile the myappprocess.c code to produce the executable myappprocess file. In step 5, we run the compile.sh file, where myappprocess file is then created in the x86 directory, as what can be seen from this snapshot. This file is then moved to the Android folder directory that was created in step 2. We then create update binary file in the Android directory and also change its permission to make it executable. Update binary file is basically the file that have instruction which will tell the recovery OS of what to do when it is executed. Once we have created the update binary file, we have completed our package, so the package is then zipped and sent to the Android recovery OS using the IP address 10.0.2.78. This IP address is the recovery OS IP address that we have checked before on its terminal with command ifconfig. This snapshot is the content of the update binary file, so from the command here, we can see it will rename the original app process32 file in the OS with app process original, and then it will copy the my app process file we have created and replace it as the new app process32. It will also change the permission of the file to make it executable. So since the package had already been sent, we boot into the Android Recovery OS and log in with username Sid and password this. This password is referred from VM manual. Once we have logged in, we go to the temp folder. We can see that the zip file we previously sent from Sid Ubuntu OS had exists in the directory. The file is then extracted and update binary file is executed. When the binary file had been executed, we can log out from Recovery OS and reboot the Android VM. And when we check again the system directory in the OS, we can already see that the dummy2 file was created here. So this marked the end of our task 2 as the package was successfully injected through the execution of app process during the Android bootstrapping process. The last task for this project is to implement Simple SU for getting root shell. Basically, the common reason users want to root Android device is to enable them to execute any command of their choice using the root privilege. However, building OTA packages as in previous tasks will only allow user to run the command that had been set in the package. So this also means that after OTA package was executed, user cannot run any other command unless they have a shell that runs with the root privilege. One of the approach to enable this is to start a root daemon during booting process and use the daemon to get a root shell. So in this task, the input and output of client program will be given to the shell process so that it also becomes the input and output devices for the shell process. By implementing it in this way, the user will have a complete control of the shell process. The source code for this task was already being provided in the lab website in simplesu.zip file. The first step for this task will be similar to the previous task. We first check the content of Android system/xpin directory, which in this case is for the presence of mysu file. As in the snapshot, there is no mysu file yet located in the directory. So in step 2, we proceed to transfer the simplesu.zip file that have been downloaded to our own PC into the downloads directory of the Sid Ubuntu OS for us to extract its content. Once the content was extracted, we compile the compile all.sh file, one of the files contained in the extracted zip file with bash command. So the compilation process and also the command to run the compile all.sh was displayed in this picture. Next, we create the standard directory structure for task 3 package, and then we create the update binary file in the Android directory, which the content of the file have a command to copy the mysu and mydaemon file to the Android system xpin directory. So when the update binary file is executed, we can observe that mydaemon and mysu file were there in the Android directory. Similar procedure with the previous task, the complete package was zipped and then sent to the Recovery OS. We then boot into the Android Recovery OS, which was logged in with root privilege using username and password root. The username and password was provided in the VM user manual. So next, once we have logged in, we go to the temp directory of Android Recovery OS, extract the zip file and execute the update binary file. When we log out from Recovery OS and reboot to the Android VM, we were able to see that mydaemon and mysu file were located in the system xpin directory. The mysu file was then executed to get the root shell. In the picture, we can see that we are currently running with the root privilege, as the input and output given to the client's program will also become the input and output of the shell process. So now we have a full control of the shell. So in conclusion, throughout working in this project, we had learned the purpose of performing Android device rooting, as we also managed to implement it ourselves through few different approaches. Other than getting to know about rooting, we were also able to familiarize ourselves in working with the Linux environment, especially when we navigate around with the files directory as well as sending a package from one OS to another. We were also able to gain understanding about the command and line of code needed in enabling users to have the root privilege. And lastly, in general, we managed to gain deep knowledge about the Android operating system itself by understanding the routing mechanism of the device. So that's the end of our presentation. Thank you for watching.